Progress. Good morning, student. This is lecture number 4. 4. We are running the series Exam Decoder. In this exam decoder, we are discussing the 5 marks question. Means those questions which have the 5 mark weightage, we are discussing for that. In today's lectures, we are discussing the 2 questions. That questions which have the weightage is 5 marks. Let us start to discuss first question. This is question number 8. The weightage for that question is 5 marks. And under the heading of the topic mathematical induction, means Pn is equal to 1 cube plus 2 cube plus 3 cube plus dot 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 plus n cube is equal to n square plus n plus 1 whole square divided by 4. Using mathematical induction, we want to prove that. Means prove the given statement by using the mathematical induction. Here is a question is asking, and the weightage for that question is 5 marks. Let us start to solve these questions. Solution for this question. Right? Using the mathematical induction, we want to prove above formula. What is above formula are given? 1 cube plus 2 cube plus dot 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 plus n cube is equal to n square plus n plus 1 whole square divided by 4. If you want to prove that formula by using the mathematical induction, by mathematical induction there are the 3 cases. In first case, you want to prove that case name is base case. In that base case, we are proving that formula is true for n equal to 1. Second case is inductive case. Inductive case. What we are doing in that inductive case? In inductive case, we are assuming that is formula, the given formula, given statement is true for some natural numbers or some positive integers. That we are considering for that statement is true for n equal to k for our convenience. After that, by using that inductive step, we are proving, in the third step, we are proving that that formula is true for k plus 1. K plus 1. And after that, case number 1, 2, and 3, above that 3 step, we are concluded the given formula is true for all natural numbers. These are 3 steps is included in the mathematical induction. Let us start to prove that. First of all, in the base case, prove this formula for n equal to 1. Means we want to prove that formula for n equal to 1, this formula is true. Means P1 are true. Put the value 1. N equal to 1 means this is a true for first terms, means 1 terms. This is true for 1 terms. We are assuming pk is true, means we are assuming that that formula is true for first k terms. And by that, using these 2 terms, we are proving that formula is true for k plus 1 terms. And after that, we are making the conclusion this is formula is true for n terms. Okay. We want to prove that this formula is true for first terms, means 1 terms. Put the value n equal to 1 in above formula. We get the p1 equal to 1 cube is equal to 1 square plus 1 whole square. We are putting n equal to 1 in above formula. This 1 cube is 1, 4 divided by 4, that is equal to 1. Means that is equal to 1. 1 equal to 1 means what we are concluding? We are concluding this formula is true for n equal to 1. Means first terms, this formula are true. Means P1 is true. P1 is true. And now in second step, we are assuming that this formula is true for some positive integers, and that means k terms. Means k terms this formula are true. Means inductive step, we are assuming that this formula is true for some positive integers k. Some positive integers. Let us that integers is positive integers means natural numbers. That is pk. This is pk is true. Means this is formula is true for first k numbers. Okay, 1 cube plus 2 cube plus dash 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 plus k cube is equal to k square. k plus 1 whole square divided by 4. It is true. Second step are true. We are assuming for that. Now, by using this second step, we want to prove the third step. Means we want to prove that formula is true for k plus 1, n equal to k plus 1. Okay. Now, third step, now we want to prove that Pn is true for k equal to, Pn is true for k plus 1. Means for n equal to k plus 1, we want to prove that. Means k plus 1 is true. Now, right, we want to prove that this formula is true for first k plus 1 terms. K plus 1 terms. Write down this k plus 1 terms. First k plus 1 terms. 1 cube plus 2 cube plus dot 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 plus k cubes cube and k plus 1 cube. These are first k plus 1 terms. And but we know by using the second step, inductive step, we know the summation for first k terms. We know the summation for first k terms. What is summation for first k terms? That is given in second step. That is k square in bracket k plus 1 whole square divided by 4. This is value for first k terms. And what is last term? K plus 1 whole cube. Now multiply, now solve this by using the cross multiplication. There is no terms available in the denominator k plus 1. Therefore, 1 are available. There are cross multiply. 1 multiply k square in bracket k plus 1 whole square is equal to k plus k square k plus 1 whole square. 4 get multiplied to this k plus 1 cube. 4 into k plus 1 whole cube divided by 4. Take common. What terms we are taking common? Take common from numerators. Take the common k plus 1 whole square. We are taking k plus 1 whole square is the common for that. And what is term remaining? K square is remaining. 4 plus k plus 1 is terms are remaining in numerator. If you are solving for that k plus 1, 4 get multiplied to k is 4k. 4 get multiplied to 1, this 4 into k plus 1 whole square divided by 4. This terms is available. Now what is this k square plus 4k plus 4? This is nothing but the expansion of k plus 2 whole square. Let us convert this into k plus 2 whole square into k plus 1 whole square divided by 4. Rearrange in the form of k plus 1. Means pk plus 1 is nothing but equal to pk plus 1 is nothing but equal to p. K plus 1 is equal to k plus 1. This is first terms. And k plus 1 whole square divided by 4. By observing the original formula which are given in the question and by observing in the last terms, if you compare that both terms, means what we are concluding? We are concluding this is formula is true. This formula is true for k plus 1. This formula is true for n equal to k plus 1. Hence, this formula is true for n equal to k plus 1 means pk plus 1 is true. By above 3 steps or by above steps, we are concluding that this is given formula is true for all natural numbers. This is our conclusions. We are making the conclusions from above steps. We are concluding that this formula is true for k plus 1 value. N equal to, no, sorry. This formula is true for all natural numbers. Formula is true for all natural numbers. Hence, what is conclusion? By mathematical induction, the formula 1 cube plus 2 cube plus dot 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 n cubes is equal to n square in bracket n plus 1 whole square divided by 2. It is true for all natural numbers. This formula is true for all natural numbers and hence this is proved. Hence this is proved. We can write to different statement in your own language. Means from above step we are concluded that this given formula is true for all natural numbers. This is also true for. Write in your own languages. If you understood, well and good. Okay. Let us start to discuss the next question. In today's lectures, we are discussing only 2 questions. After that, next lectures, we are discussing the 2 questions. This is question number 9. That questions have the 5-mark weightage. Questions have the 5-mark weightage. And what this is the questions under the heading for the mathematical induction. Prove by the mathematical induction 3 power n minus 2n minus 1 is divisible by 4. We want to prove that 3 raised to power n minus 2n minus 1 is divisible by 4. We want to prove that. By using mathematical induction, we want to show that this is formula is true for all natural numbers. Means n by all the values of n, this is formula is true. Using mathematical induction, we want to prove Pn is equal to 3 raised to power n minus 2n minus 1 is divisible by 4. We want to prove this is true for all natural numbers. In the base case, in the mathematical induction, there are three cases are involved. We are well known for that. The first is the base case. We want to prove that is a formula is true for n equal to 1. And after that, we are considering in the inductive step. Step number 2 is inductive step. We are considering that formula is true for n equal to k, means we are assuming for that. By this assumption, we are using the next step and proving that formula is true for n equal to k plus 1. We are proving that formula is true for n equal to k plus 1, and hence from first step, second step and third step, we are making the conclusion this is formula is true for all natural numbers. Okay. The first step, we want to prove that this formula is true for n equal to 1. First step. What is Pn? Pn equal to 3 raised to power n minus 2n minus 1. Put n equal to 1 in above formula. If you are putting n equal to 1, 3 raised to power 1, 2 multiply 1 minus 1. This is equal to 3 minus 3. 3 minus 3 is equal to 0. And 0 is divisible by 4. Means we can divide 0 by 4. Okay, means it is true for n equal to 1. It is true for n equal to 1. Now we are assuming that the next step is the inductive step, assuming that it is true for some positive integers. We are assuming that it is true for some positive integers, and let us consider for that it is true for k integers, first k integers. It is true for first k integers. Let us k put, that is means the 3 raised to power k minus 2k minus 1, it is divisible by 4. It is divisible by 4. Means what is mean by divisible by 4? Means we are considering the first terms, means these terms which are available in the bracket 3k minus 2k, 3k minus 2k minus 1, it is divisible by 4. Means what? This term is multiple of 4. What we are concluding? This term is multiple of 4. Means pk is true. Means 3k minus 2k minus 1 is equal to 4m. We are considering this term is multiple of 4, means this term is divisible by 4. Write down these terms in the multiple of 4. M belongs to in the natural numbers. M belongs to in natural numbers. Means if we rewrite the arrangement, means 3k is equal to this minus 2 which are available in the left hand side, take this right hand sides, and minus 1 is also available in the left hand side, take this other side for that. Means 4m, whatever be the, what is value for 3 raised to power k? 3 raised to power k is the value 4m plus 2k plus 1. This is value. Now we want to prove that this is value for 3 raised to power k. Okay, we are getting from this value 3 raised to power k from assuming that this is second step value. Now we want to prove that what terms we want to prove? Now we want to prove this is a true for n equal to k plus 1. Now we want to prove that this formula. Now we want to prove that pk plus 1 is 2. Now we want to prove that, means 3 raised to power k plus 1 minus 2 in bracket k plus 1 minus 1 is divisible by 4. We want to prove that. Okay, let us write pk plus 1. Pk plus 1 is equal to 3k plus 1, 3 raised to power k plus 1 minus 2 in bracket k plus 1 minus 1. According to law of indices, we can write this 3k plus 3 raised to power k plus 1 in the form of 3 raised to power k into 3 raised to power 1, and multiply this 2 in bracket k plus 1, means minus 2k minus 2 minus 1. What we are getting in the next step, and write whatever may be the value for 3 raised to power k, which are present in the second step. What is value we are getting? From second step, we get the value. The value of this 3 raised to power k is 4m plus 2k plus 1. This is value which are available in the second case. Means second step. Okay, put the value of 3k plus 3 raised to power k. Okay, we are putting this value and multiply this. 3 multiply 4 is 12m. 3 multiply 2 is 6k. 3 multiply 1 3 plus 3 minus 2k minus 3. 3 plus 3 minus 3 get cancelled, and 6k minus 2k, which is 4k. This 12m as it is, 4k plus 4k. Take the common 4 from this both terms is 4 in bracket multiply 3m plus k. Now let us consider n is a different terms which are 3m plus k. Means this is terms, whatever may be this terms is available, pk plus 1 is 4n. Means pk plus 1 is divisible by 4. What we are observing? Means pk plus 1 is divisible by 4. Means pk plus 1 is true. From this above 3 step, we are assuming that from all above step, by mathematical induction or by principle of mathematical induction, Pn is true for all natural numbers. Pn is true for all natural numbers. Means what? What is your conclusion? That is, means 3 raised to power n minus 2n minus 1 is divisible by 4. It is true for all natural numbers. Hence, it is proved. Hence, it is proved. Now, we have completed the two questions. We are stopping here. And next lectures, we are discussing different for that. Okay, let us stop.